Hello friends, welcome back to my channel. So today we will learn about three techniques that will improve the performance of your RAG significantly. So let's get started. As you all know, in a RAG based pipeline, a user query is first sent to LLM. LLM then access the knowledge DB or your vector DB in most of the cases, and then retrieve the relevant documents related to the user query. And then those retrieved relevant documents are then again passed back to the LLM, and then based on the previous knowledge and the current user query, LLM generates the answer. Most of the time you see that there are issues if you directly pass the user query to the knowledge DB and you aren't able to efficiently retrieve the information. So as in the last video we discussed a few strategies of embedding data rightly into the knowledge database, right, so that you can basically fetch data efficiently on the runtime. We discussed two techniques about embedding the summary in the each chunk and then basically choosing the right model and then choosing the right chunking strategy. But in today's video, we will discuss about three strategies with which you can efficiently retrieve the stored data. So for this video, we will assume that you have stored the data in the most optimal way. Now we'll discuss how you optimize the retrieval of the information. So the first strategy we are going to discuss is query expansion. Okay, so in query expansion, what happens is you have a user query, then user query is sent to LLM. LLM then expands this query into multiple queries. In this case, I've just expanded it into 3 queries. Okay, and then you retrieve the results for each query from the knowledge DB. Cool. And then you fetch like top k documents. So now you get n into k documents. In this case, you will receive 3k documents, right? And then you merge all these documents. So you have 3k documents over here. And you send all these 3k documents into a Reranker. Why Reranker? I'll explain you with the example in a bit. But what Reranker does is Reranker will get all these 3k documents and this user query, and basically it will filter out top k documents which are most relevant to the main query. Now you have received 3k documents, but not all the documents might be relevant. So what Reranker does is Reranker just sends the top k documents which are most relevant. Now, how does this improve the performance of RAG? Let's discuss that. So, let's say user asks the query, how to remove my profile. Might not be able to find, you might not be able to find the relevant information, right? But instead of it, what LLM will do, LLM will expand this query into 3 queries. One query will be something like that. I'm again giving you an hypothetical example. One query will expand it to how to pause the profile, okay? How to deactivate the profile, how to delete the profile. So your LLM will divide it into the these kind of queries. So you will find all the documents which are relevant to these queries: how to pause the profile, how to deactivate the profile, and how to delete the profile. Say you had set the k like 5, so you will get 15 documents in total, right? But now you need a Reranker. What will Reranker do? So basically it will receive your main query, how to remove my profile, and it will fetch all the it will get all the documents. Now your Reranker will know which documents are most relevant to the main query, because if there are documents related to deleting the profile, then documents related to pausing the profile might not be so relevant. Even if you had asked to remove the profile, sometimes you might be interested in how to pause the profile. So basically it can be vice versa as well, and you might not be able to directly match the documents with remove the profile, but you might be able to match the lot of relevant documents to pause the profile or deactivate or delete the profile, because that's how the knowledge is stored in the DB, right? So that's how this query expansion helps you retrieve the better information from your database. So this is the first approach that I wanted to discuss. This is the query expansion, where you send a query to LLM creates a multiple versions of that query and then send it to knowledge database, fetches the results are then sent to Reranker, and then Reranker gives you the top tier results. Mind my word, Reranker is very important over here, and this is again one of the most difficult part in the LLM pipeline, because generally Rerankers are slow, so it adds a lot of latency in your pipeline. Secondly, the second strategy I wanted to discuss was query decomposition. In query decomposition, you break the query into multiple queries. You break the main query into multiple queries. Now you may ask, why do we need to do that? In some scenarios where when you search the whole query, you might not get the result, but when you search the subparts of the query, you may get the results, and then you compare those results and send the final output. So pipeline remains more or less same. So in query decomposition, what happens is, so let's say user asks a query, which country make more profit from selling software, India or China? Now you see, right, in your knowledge database, there might not be a direct answer to this question. But in your knowledge database, there can be two answers. One related to how much money India made in the last year by selling software, and another answer can be how much money did China make by selling software in the last year. So if your LLM breaks this query into two parts, basically one is how much money India make, and another query that it generates is, so now you may find separate results to this query, and then when you have this query and you send this query to Reranker, then Reranker will consider both the queries because both are relevant, and then basically will send the results from this query and some results from this query to main LLM, and LLM will use this data to answer like, okay, which country made more money, right? So this is the second approach, which is query decomposition, when you break a complex query into smaller retrievable queries, and then you pass those queries to Reranker and then LLM to get a efficient answer. And the third technique is bit different and bit non-intuitive, like these were still intuitive techniques. The third technique is hypothetical doc generation. So what happens in hypothetical doc generation? In this technique, you generate, so you get a query, then query is passed to LLM, then LLM generates a hypothetical doc that basically a similar doc to a document in which related data can be present. So for example, as we were discussing this, which country make more money. So for this, LLM will try to generate a news article maybe stating that, okay, in the financial year this India sold this much amount of software, and then these were the companies who made the most sales, etc., etc. Although it will be a completely hypothetical doc, but LLM will try to generate such, and similarly it will generate such doc for China. Now why will it do that? So as we know, in your vector database we had embedded the knowledge. So knowledge is generally present in the documents, PDFs, news articles, FAQs, similar kind of documents. With hypothetical doc generation, what happens is your chances of matching a relevant document increases. Why? Instead of searching a particular keyword which might be present in lot of non-relevant documents, okay, maybe there was an article in, let's say, agriculture related PDF, where they might have said like, okay, India made this much amount of sale in software, but India did a very less sale in agriculture. While this information is true, it might not be 100% accurate because the context is different, but your LLM might fetch such docs because the relevancy to the keyword is very, very high. But with hypothetical doc generation, when it generates a doc that looks like a economic report of a software news, right, or software related news, the chances of matching with the right document increases exponentially, right? Basically, at the end of the day, it increases your precision. What is precision? Precision is number of relevant documents received, but divided by total number of documents retrieved from the database. LLM generates a hypothetical doc, and then basically this hypothetical doc is passed to vector DB, and retrieved result and results are retrieved, which are again passed to Reranker. And this hypothetical docs, this is not a single doc that it generates multiple docs, right? One doc may be for a news article, uh, one doc may be for some FAQ, one doc may be for some PDF, etc. So such similar docs are generated and then they are passed to VectorDB. So these are the three techniques that we discussed in brief. One is query expansion, other is query decomposition, third is hypothetical doc generation. In reality, mix of these three techniques is deployed. So generally you deploy all three techniques, and when query comes, you execute three processes in parallel. One does query expansion, another does query decomposition if it is needed, and the third does hypothetical doc generation. And then each technique is, let's say, generating n queries. So you have now 3 n queries. For each n you are retrieving now k documents, right? K documents over here, and then you have 3k documents from each set, where you get 9k documents, and then you are passing 9k documents to a Reranker, and then you can deploy a global Reranker that will like, instead of these individual Rerankers, now you can deploy a global Reranker. Okay, now you have passed the main query as well as results from the each technique to the Reranker. Now basically you received 3k results from query expansion, you received 3k results from query decomposition, you get 3k results from a hypothetical doc generation technique. Now you get 9k results over here, right? And then your Reranker compares actual documents. So remember, over here you have embeddings which you have done independently of the user query, but Reranker has the actual query in plain English, and then your retrieved documents in plain English, not embeddings. So Reranker can compare the actual meaning of the query with the docs and then generate the k document. So with this technique, you can improve the efficiency of your retrieval significantly. I hope this video helped you. These techniques are fairly simple to implement, right? Because you have to just pass the query to LLM will give you answers, and then you have to execute that query as a main query on the DB. I'm going to end over here. Please feel free to leave a feedback or comment. Thank you for watching.